better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
Hello students, today we are going to look at one of the gas laws known as Graham's law of diffusion. Graham's law of diffusion. As an introduction, diffusion is defined as movement of particles from a region of high concentration to a region of low concentration. So diffusion is a movement of gases from a region of high concentration to a region of low concentration. Now, when investigating how fast or how slow gases diffuse, we use a glass tube. In this experiment, we are going to perform an experiment where we are going to use two gases to investigate how we can show gases diffuse. We are going to use a gas known as ammonia gas. The other gas we are going to use is a gas known as hydrogen chloride gas. Now these two gases have different masses or different weight. The weight of ammonia gas is 17 grams per mole, and the weight of hydrogen chloride gas is 36.5 grams per mole. Now, ammonia gas is emitted by concentrated ammonia solution, and hydrogen chloride gas is emitted by concentrated hydrochloric acid. Now, in this experiment, we dip a cotton wool inside ammonia solution, and then we place it on one end of the glass tube. Then on the other end of the glass tube, we place cotton wool that is soaked in concentrated hydrochloric acid. Concentrated hydrochloric acid. Now this cotton wool here will emit hydrogen chloride gas, and this cotton wool here will emit ammonia gas. When the two gases are emitted at the same time, because the two cotton wools are placed at the same time, ammonia gas generated here will diffuse this direction, and hydrogen chloride gas generated here will diffuse towards that direction. Where the two gases meet, they will react and they'll form a compound which is seen as white in color, known as ammonium chloride. And the equation is this: ammonia gas will react with hydrogen chloride gas to form ammonium chloride gas, which is seen as a white fumes or white fumes. Now, where the two gases meet, the white fumes is seen. When this experiment was performed, the gases were found to have been met closer to the side of hydrogen chloride gas. Actually, it was 8 centimeters from the end of hydrogen chloride gas. Ammonia was seen to have diffused a distance of 12 centimeters. Now, the length of the whole glass tube was 20 centimeters. So ammonia diffused 12 centimeters, hydrogen chloride gas diffused 8 centimeters. Clearly, you can see ammonia gas diffused a longer distance. Now, if you have to look at the rate of diffusion of ammonia, you get it by take the distance that is diffused, divide by the time taken, the two gases met after 5 minutes. So divide by 5 minutes, and you can see the rate of diffusion of ammonia is 2.5 centimeters per minute. Now you've got to look at the rate of diffusion of hydrogen chloride gas. It diffused, this is the rate of diffusion of HCl gas, diffused 8 centimeters length within 5 minutes. Therefore, the rate of diffusion of hydrogen chloride gas is 1.6 centimeters per minute. Now, if you compare the relative rate of diffusion of the two gases, you take the rate of diffusion of HCl, that is ammonia rate, versus the rate of diffusion of HCl, you get it by rate of ammonia 2.5 centimeters per minute divided by rate of HCl, which is 1.6 centimeters per minute. If you divide the two, the answer you get is actually 1.5. What does that mean? This means that ammonia gas diffuses 1.5 times faster than HCl. So ammonia gas diffuses 1.5 times faster than HCl. Therefore, we can conclude that ammonia gas, which is lighter with 17 grams of mass, will diffuse faster than hydrogen chloride gas, which diffuses, which has a mass of 36.5. Therefore, our conclusion is the lighter the gas, the faster the rate of diffusion. The lighter the gas, the faster the rate of diffusion. This experiment was done by a scientist known as Graham, and Graham came up with the law known as Graham's law of diffusion. States this: Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its density at constant temperature and pressure. The rate of diffusion of a gas is inversely proportional to the square root of its density at constant temperature and pressure. If you were to express this in a mathematical expression, we would say rate of diffusion is inversely proportional to the square root of the density. Let us take R for rate, D for density. Therefore, we would say this: R is equal to is inversely proportional to 1 over D. To remove this sign, we add an equal sign and a constant. R is equal to K, which is a constant, over D, square root of D. Now let's make K the subject. We'll make it the subject by cross multiplying both sides or dividing square root of density both sides. You get rate times density is equal to K. Suppose we have two gases, gas A and gas B. Assume you have two gases, gas A and gas B. You would say rate of gas A is multiplied by density of gas A is equal to K. If you have the second gas, which is gas B, rate of diffusion of gas B multiplied by density of gas B is equal to K. Now, mathematically, if K and K are equal, that would give us, therefore, to conclude the rate of gas A multiplied by density of gas A is equal to rate of gas B multiplied by density of gas B. Then let's put rate to one side and density to the other side. What you do is divide by rate of gas B by rate of gas B. We cancel that. Then divide by density of A, divide by density of A. We cancel that and that. At the end, you get rate of gas A over rate of gas B is equal to density of gas B over density of gas A. Now, this is the first equation used in Graham's law. This is the first equation that we use in Graham's law. The second equation we use is, we shall discuss the second equation we use in our next time. We shall be discussing Graham's law.